lesson, we're going to continue on relations and functions, but today's objective, I can write, graph, and evaluate functions. I can write, graph, and evaluate functions. Let's read it together. 1, 2, 3. I can write, graph, and evaluate functions. So write your, it's already down there, right? I gave you the notes. All right. So I want you to underline or circle with red where it says write, graph, and evaluate, and with green where it says function, because that's the concept that we're going to be looking at today. All right. So with that said, you have steps, but we need a Freyer model just to clarify functions. So sketch a Freyer model underneath the steps that I gave you. Well, it's enough so that you can write on it. Here we go. So what are functions? We already covered the basic definitions yesterday, but here it goes again to clarify. Functions are a relation that assigns exactly one output value for each input value. A relation that assigns exactly one output value for each input value. Copy this example down. Number 1, it's a relation. Open bracket, parentheses, -2, 3, comma, the other order pair is -1, 4, comma, the other order pair is 0, 5, comma, the other order pair is 1, 6, comma, and the last one is -2, 3. Cool. Next example, here it goes. Y equals 2x plus 1. Y equals 2x plus 1. The next example, y equals x squared plus 1. Y equals x squared plus 1. And the last example, y equals x cubed plus 2. Y equals x cubed plus 2. Non-examples. Here it goes. Copy this one down. -2, 3. -1, 4. 0, 5. 1, 6. And -2, 7. All right? And copy this, the last non-example. It's a graph, so get ready to sketch. All right, here we go. Copy that. Copy that, please. Okay, here we go. Now, I'm going to come back so I can show you why this graph is a non-example of a function. Okay? Today we're going to verify that, and we're going to have that clear. However, with this non-example that I gave you up here, it's specifically a non-example because one reason. Think about it. Why is this a non-example? Don't say it out loud. Keep it to yourself. Okay, share with your neighbor, please. So, now that we know why these are examples and these are non-examples, let me just give you over here, guys, everybody look up. We're going to get some graphs so you can see what these functions look like. And this is a revisit pretty much of what you guys did last year in pre-algebra. So check this out. I'm going to graph this one first. Okay? So for this one, if I was to graph it, check this out. Everybody look up, please. If I was to graph this one, I'm going to graph that in red. Oh, sorry. I'm going to graph that in red. Okay? So if I wanted to graph that in red right here, this function should look something like this. There it is. So this is this. Now let me show you the graph for this one. Let me get my coordinate plane. There it is. And let me show you what this function looks like. This is this. This is this. Let me graph the last one. Here we go. And I'm going to graph this one in green. So check this out. This graph looks like this. Okay? So check this out. So a refresher from last year, functions. This is called a linear function. This one's called a quadratic function. And this one, since it has an exponent of 3, it's called a cubic function. Okay? So I just wanted to show you what it looks like in a graph representation. However, going back to our sphero model. Before I continue, can you copy these graphs, please, so I can give you the next part? Now back to our Freire model. Here we go. So the most important thing to remember about functions, number one, that they are what? Are relations, but they have what? Specific. One output for every input. So that goes here. They are relations, and there's exactly one output for each input. They are relations, and it's one output for each input. They are relations, and it's one output for each input. They are relations, and there is one output for each input. Okay? So, now back to our steps. We have our steps already, right? Steps. Step 1, write a rule for the function. So, let's circle and underline steps so it can be easier to memorize. Step 1, write a rule. Write a rule. Step 2, graph the function. Graph the function. Step 3, test your graph. Test your graph. Step 4, evaluate the function. Evaluate the function. So here go all 4 steps. Step 1, write your rule. Step 2, graph your function. Step 3, test your graph. Step 4, evaluate your function. Step 1, write a rule. Step 2, graph the function. Step 3, test your graph. Step 4, evaluate your function. Tell your neighbor the steps, please. Now that we have our steps, I want you to copy this next example, please. Oh, before that, on the left-hand side of the Q, right there on your notes, write these vocabulary down. Vocabulary. Here we go. First vocabulary on the Q side, domain. And you're saying, Mr. Q, didn't we write this yesterday? Yes, but today I want you to understand that the domain is independent variable. That's the name of it. The domain is the independent variable. 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 Tell your neighbor what the domain is. So, if the domain is independent, then therefore the range is dependent variable. If the domain is independent variable, the range is dependent variable. 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 Okay? So once again, domain independent, range dependent. 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 All right, copy this example down on the right-hand side. Here we go. Example number 1. It says, determine a relationship between x and y values. Write an equation and graph. Determine a relationship between the x and y values. Write an equation and graph. The relation that they give us is -2, -6, -1, -5, 0, -4, 1, -3, 2, -2, and 3, -1. Copy that down, please. Pens down, eyes up here. So I'm going to go through the entire process. I need you guys to focus because this is the only example, and then I'm going to have you try one. It's very simple. It's very easy. It's just a lot of steps. Here we go. Pens down, eyes up here. So our steps were write a rule. Write a rule. In order to write a rule, number 1, I need to have a table so I can see a pattern. So check this out. I'm going to go ahead and get a table started. But this time, instead of doing a table like this vertically, I'm going to do one horizontally like this. And you're just paying attention. And I have x and I have y. We said that x is the domain and also known as the dependent variable. Yes? Y is the range and also known as the dependent. My bad. So then domain is independent, range is dependent. So here we go. My first order pair, -2 of x, -6 of y goes right here. -2, -6. Next one. -1, -5. -1, -5. You see what I'm doing? Next one. What is the next one? 0, -4. 0, -4. Do you know how to fill in the rest? Okay, copy that and finish up the rest, please. All right, so to finish this, the next one is 1, -3. The next one is 2, -2. And the next one is 3, -1. All right. So far, so good? All right, pens down, please. Eyes up here. Let me show you how to get a rule out of a table. Here it goes. This is how we write an equation. An equation is a rule that comes out of a relation. So here we go. Everybody look up, please. So now, I'm going to see the independent variable. This is my input. What is happening to x? What can I do to x to get this output? To get this output. So think about it. This was -2. It became -6. -1 became -5. 0 became -4. 1 became -3. 2 became -2. 3 became -1. Think about it. What's happening to these numbers? Don't say it out loud. Keep it to yourself. What happened to these numbers that we're getting this output? Some of you already saw it. Those of you that haven't, think about it. It has a particular pattern or rule. Okay? All right. Share with your neighbor. What is the pattern? All right. Here we go. So, I heard you guys say that they're adding a -4 to each of these. Let's see. If I add -4 to -2 becomes -6. This one becomes -5. This one -4, -3, -2, and -1. Does everybody see that? Now check this out. To write a rule, pay attention please, or you're going to miss it. To write your rule or your equation, you need to write y equals, you leave a blank, and then you write x, and you leave another blank. Copy that, please. All right, here we go. Pens down, eyes up here. Let me show you how to write the rule. What did we say was happening to x to get y? No. Subtracting 4. So therefore, x minus 4. And this is our rule. Okay? So what was step 1? Write a rule. Did we do that? Yes. Number 2, graph your function. So for that, we're going to need a graph. So I need you to sketch a coordinate plane right here, right next to, like this, like this. So now here we go. Let's look at our domain. Let's look at our all x values. Everybody look up to the screen, please. Look at all these. I'm going to start with 0. I know that this is my number line. Here's 0. Okay? What's to the left? -1 and -2. Is that all we need for my x value? Yes. What else over here to the right on the x value? 1, 2, 3. All right? Now, this is x. For y, what values do I need? -6, -5, -4, -3, -2, -1. So I'm going to start right here at -1, -2, -3, -4, -5, and -6. All right? So let's plot our points and graph our function. Let's see. So my first point, and I'm going to do this in red. Everybody look up, please. I'm looking at this one right here. This one. -2 of x, -6 of y. -2 is right here. -6 of y is down here, so I plot my point. Next one. -1, -5. -1 of x, -5 of y. It's about right there. Next one. 0 of x, -4 of y. 0 of x is right here. -4 of y is right there. Next one. 1 of x, -3 of y. 1 of x, -3 of y. Next one. 2 of x, -2 of y. 2 of x, -2 of y. And the last one. 3 of x, -1 of y. 3 of x, -1 of y. Now that we plotted our points, we need to graph our line. Let's see. Let's graph a line. I'm going to do that in red. All right. Did you ever see what we did? Okay. So here we go. So far, step 1, write a rule. Did we do that? Yes. Step 2, graph your function. Yes. Step 3, test your graph. So let's just double check to see if this is a function. Here we go. With your technology, your advanced technology that I gave you, okay, you're going to place that flat on your desk, and it should look something like this. Here we go. You're going to place it flat like this next to your graph, your paper clip, and all you're going to do is move it from left to right and see if it intercepts that graph. Does it intercept it? Yes. But it only intercepts it at one point, doesn't it? Look at that, all the way through. At one point, 1 point, 1 point, all the way through, all the way through. If it only intersects at 1 point, then it is a function. So this one, we're just going to write, you're going to write yes, function. So far, so good? Yeah. All right, so now, I said I was going to come back to that example on the Freyer model. Is that correct? Yeah. So let me go back to the non-examples. on the Freyer model. Look at this one. Everybody look up, please. Look up to the screen. I'm gonna test this one to see if it's a function. I'm gonna get my technology, advanced technology that I gave you, and I'm gonna scan it from left to right. As soon as it touches and two places on that function, on that relation, it is not a function. Who sees that it's touching two points? It's touching right there and right there. Do you guys see it? So as soon as it touches that 2, it is not a function. Why? Because we already said that for each input, it cannot have 2 different outputs. So here, for this one, it's touching how many? 2 different. So this is not a function. Okay? So with that said, let's go back to our current problem. So let's see. Step 1, write your rule. Step 2, graph your function. Step 3, test your graph. Did we do that? Step 4, evaluate your function. Evaluate your function. So pens down, eyes up here. Now this is very important, so make sure you're focused on the screen. As soon as we know, everybody look up, that this is a function, in order to let people know that this equation is a function, look what I'm going to do. Everybody look up. Tell your neighbor what changed. What changed? Okay. Who sees that I changed the y for the f and the x? Okay, now check this out. Why did I write this? Because what letter does function start with? F. In order to let people know that this equation represents a function, I write it as f of x. That's how you pronounce this. Everybody look up. This is pronounced f of x. F of x. Or if you want to say it completely, function of x. Function of x. F of x. Function of x. This is what we call function notation. Copy that down, please. Function notation. All right, so pens down. And the last step, evaluate the function. Now that I have my function here to evaluate it, everybody look up, please. All I need to do is add one more value to the table. Check this out. I'm going to add here another space, and I'm going to add, and I'm going to do it in red so you can see it. What's the next value? See, I got 0, 1, 2, 3. So the next one is 4. And that's going to represent x. So instead of x here, what am I going to write? 4. So I'm going to substitute in here 4 and in here 4. And I bring everything else down. The f, parentheses, the equal. I open up parentheses whenever I substitute here for a variable, minus 4. Are we there so far? So check this out. What is 4 minus 4? 0. So in order to read this, this is f of 4 equals what? 0. So guess where that goes? Right there. That's how you evaluate a function. Let's try another one. And this one you don't have to copy it. What would be my next number to substitute and evaluate? 5. So check this out. If I substitute here at 5, what do we have? 5 minus 4 equals what? 1. So therefore, f of 5 is 1. Everybody see what I'm doing? Okay, so let's see. 4 easy steps. Number 1, write a rule. What did we have to do to write a rule? We needed a table. There it is. Did we write the rule? Yes. Step 2, graph your function. There it is. Step 3, test your function. There it is. Test your graph. 4, once you know it's a function, you write it in function notation. And then from there, you evaluate. Are we there? Okay, last but not least. Everybody look up, please. Last thing. Oh, sorry. Sorry. Okay. If we look up, please. Look at this one. It says, graph the equation. To graph this, number one, we need to solve for y. Everybody look up. Is it already solved for y?
No.
Yeah. Did everybody see that? Okay. Next, we need an input-output table. Do they give us any values? No. Well, guess what? You're going to make them up. But I need you to start from -2. What would be the next one up? 0, 1, 2, and 3. Now, do we know how to evaluate using those values? Yes. Once you evaluate this, that's how you get your values of y, and you know how to graph from there. Yes.
That's when they say x is something and then y is something.
Yes. Make sure you read into this piece at the end of the lesson. Homework for tonight is on pages 218. No, 219. Numbers 1 through 35 odd. Have a good one, everyone. Enjoy your homework. See you guys tomorrow.
My lock picker, my
No.
murder weapon.
No.